So thank you all for coming, and thank you, Shravan, for your kind introduction. He's a great mentor to have, and throughout these 15 weeks, we are all coming from different backgrounds. He took us from there and made us data scientists. So thank you. Today I'm going to talk about CuLo. I hope it's a cool name, but looks nice to me. So CuLo stands for customer loyalty. So we will be talking about customer loyalty today because that's a significant matter for almost every company, I believe. And we are going to use some geolocation based data to predict customer behavior and attitudes, and how, based on what factors they're staying loyal to a certain company. Here's my email. I don't have an AI domain. I was gonna get bugter.ai, but it was taken. And here is the river Jiang was born next to. Okay, so who is the target audience for CuLo? Who would benefit from this service at most? In this case, we are going to look through the case of customer loyalty through a data from a credit card company. And what they basically did was pushing some promotion and coupons between restaurants and customers. And what they want to do in this case was to make both sides happy. So credit card companies may benefit from this a lot because they need to manage these promotions. And also restaurants and food companies may benefit from this because they want to know who will be staying loyal to them and to their products, services. So understanding customer behavior is essential here to keep people coming. So why CuLo is the question I will answer now. It's going to be helping credit card companies in managing promotions. It will help advising restaurants on customer loyalty. And on the customer side as well, it's going to it can provide personalized food recommendations to customers. I have a little side tool that I also want to mention, which I call Data Explorer. It's a small, simple web app for easy data exploration and model building. We'll also talk about that. So for this one, who is the target audience? It's mostly addressed towards data science teams to easily deploy models and to be able to communicate them easily. And also growing companies with lacking the technical knowledge to build machine learning models or to do data analysis, it may be helping them as well. So basically it addresses the absence of technical expertise. It has and will have a user-friendly interface. It's practical and it's easy to deploy. So what can this deliver? What can this tool deliver? It may be used for data exploration, data visualization and reporting, and model building. So this was the execution timeline throughout these two projects. We went through all steps of machine learning model building workflow, starting from business question, then followed by data wrangling, feature engineering, model building, and at the end, for a time period deployment and our Shiny app development. So before going into Data Explorer again, I will talk more in detail about CuLo. So the business question we start here is, as I mentioned, customer loyalty. The data comes from a payment brand, a company in Brazil called CuLo. And this company built partnerships with merchants to offer promotions to their customers and to their cardholders. So the deal here is to make both sides happy. Do these promotions work for either the customer or the merchant? Do customers enjoy their experience? And do merchants can see customers keep coming? So the key point here is personalization, like making these recommendations personalized for customers to keep both sides in business. So the data I have used in this case consisted of several data sets. We had a training test data sets like any machine learning model with 202 observations in this case. This one is lacking the target variable, obviously. And we also had some information about historical transactions in historical credit card transactions, and also a data set on merchant. So the process was merging these data sets and finally predicting the target variable in the test set. So initially we had gone through, I had gone through a data exploration phase and to some extent data cleaning. This is the histogram for the target variable. So we can say that it's fairly normally distributed. So this is going to help our decisions in the later phase of model building. After that part, I went through feature engineering, which mainly consisted of mapping the categorical features and then creating aggregate values as additional features to be able to predict better customer loyalty. So finally, we have our model. Our outcome, the outcome we are trying to predict is, as I mentioned, customer loyalty. And our features mainly based on, there were a wide variety of features, but there are mainly geolocation variables and also variables that I extracted from time variable. And then the aggregate variables that I have created through the feature engineering process. So the model I deployed was light gradient boosting, light GBM. It's a powerful model and performed well for this case. So as a result, I have achieved to predict customer loyalty score with a mean squared error of 3.84, which is quite low for this scale. And here we have a graph of feature importance. So this basically says what are the things are most important to predict customer loyalty. So going through these different concepts, variables, we can understand customer loyalty and customer behavior better. As a conclusion, what is this contributing to? It is through this model and using this data, the financial institutions who are offering promotions to customers and between customers and merchants can be helped using this knowledge of what is important. And also understanding customer behavior through knowing what is important to them when they are being loyal to a company. Through having this knowledge, any company can benefit and try to be more in a way which will keep their customers loyal to them. So that was the end of CuLo part of it. So Data Explorer is a simple web app at its initial phases. So I will briefly show that, and that will be it. As I mentioned in the beginning, it's a tool to be used to analyze data, visualize and explore data, and it has still a lot way to go, but we can go through this. So using this part, we are browsing and uploading the data.
And Emir, is this shiny?
This is our shiny.
Okay.
If you ask me why I used R, because I like R. It has a spirit, I believe. Python doesn't have much. So after uploading it there, we have header options and separator options to have the data. And as display options, we can display all of it or just the head part. Okay. So here we can select variables that we want to see, and it will show up here. And we can add features based on what we want to see in the data set. And in this part, you can customize how much you want to see here. And we have a searching tool through the data set, and you can go through the pages to see if you want to explore the data set more. And here for data visualization and exploration, we have a select box of variables, and through that we can create histograms in this tool. Right below that, it gives us, based on what we choose as our outcome variable, it gives us some summary statistics. And we can customize the histogram through interactively. And the next stages for this will be adding features on feature engineering and model building. So after having that, we will have options of models, and we can go through and deploy those models just by clicking them and without any code running by the person using it. Thank you. Customer loyalty score is built based on the transactions within the data and historical transactions that customers have been using in certain places. A main example here, and they have done, was restaurants. So keeping going that restaurants, and it's following that value, it has been memorized and has been built this customer loyalty score.
What is the problem you're trying to solve here? What kind of problem is that?
So
Is
here,
that a ranking problem? Is that a classification problem? What kind of problem is that?
this is a regression problem. So it's going through a scale, not a classification problem, for regression problem.
Okay. And any gotchas you found?
So the gotcha I have found is that the historical importance of historical transactions and how recently a customer went to a place is an important predictor of loyalty. So the frequency of recent historical transactions is very important to keep customers loyal.
You went through a couple of changes in the project one, right?
Yes.
There was project number 1 that did not take off.
Yeah.
And you had a learning moment. What was that learning moment?
That learning moment in the previous project that didn't take off was on scraping Twitter data and analyzing online content popularity. And the aha moment I had there was how long can data collection may take. So that was too long for the time period we had for this project. So that was a learning moment. Like, getting the data is an important part of this process.
So for you, I think it's a quick realization that the longer the collection takes, you really cannot get to the final data product.
Yeah.
Anybody else have questions? I mean, I know I'm pretty intimate with this process.
So when you chose a gradient boosting method for doing your modeling, what were the competing modeling approaches you could have taken? Why was gradient boosting the right answer?
Thank you. Good question. Since this was a regression problem, a linear model can be deployed for this. For XGBoost, like gradient boosting instead of light boosting could also be another option, which would, I believe, again, could perform fairly good. But this one performed better, so I went with light gradient boosting in this case.
And what was your criterion for performed better?
For performance, I have used RMSE, the root mean squared error and mean squared error. So comparing these and comparing the predictions, going through each iteration, this one had the lowest error.
Okay.
So I have gone with IGBM. Thank you.
Thank you.